This will surprise you. ChatGPT never actually reads your sentence, it shreds it into pieces first. And the technique it uses to do that? Invented in 1994 by a guy who just wanted to save disk space. LLMs are basically deep learning models, trying to do one job and one job only, predict the next token. Now, what in the world is a token? Let's think about it the way a human brain does it, because honestly, that's the only reference point we've got. Think back to when you were 4 or 5 years old, holding a picture book, sounding things out. C-A-T, cat. You weren't reading, you were decoding, letter by letter, like a tiny human cryptographer cracking the code of cat for the very first time. Fast forward a few years, you don't sound out cat anymore. You see the word and the meaning just arrives. No decoding, no effort. Your brain skipped a step. Fast forward even further, you're an adult now, scrolling through your phone. And you can read a sentence like, "The stock market tanked today," and instantly feel the dread, without consciously parsing a single letter. You're not reading words anymore. You're reading meaning. Sentences walk straight into your brain and drop off a fully formed idea, like a pizza delivery guy who has a key to your apartment. That's decades of neurons quietly firing, wiring, and rewiring themselves so you could go from CAT to instant comprehension. Now here's the plot twist. A neural network has none of that. Zero. It has never been a confused 5-year-old with a picture book. It doesn't know what a letter is. It doesn't know what a word is. It definitely doesn't know what a sentence is. It only knows one language, numbers. So we've got this insanely powerful, insanely dumb brain, a math engine capable of billions of calculations per second, and we're trying to teach it Shakespeare, Reddit threads, breakup texts, and legal contracts. And it can't even read the letter A. Somebody had to solve this problem. That somebody is where this story actually gets interesting. But first, the obvious bad idea. Easy, you think. A equals 1, B equals 2, C equals 3. Done. Ship it. Except language isn't a bag of letters thrown on the floor. Order matters. Brutally so. Dog bites man and man bites dog use the exact same letters. Same numbers if you're numbering letters. But one is Tuesday's news and the other is the headline that gets a reporter a Pulitzer. Meaning doesn't live in the letters. It lives in the relationships between letters, words, and their order. And a neural network, fresh out of the box, understands relationships about as well as your cat understands your Wi-Fi password. So numbering letters is out. What about numbering whole words instead? Give every word in the dictionary its own number. Cat equals 4,021. Dog equals 8,843. Simple, right? Except English doesn't sit still and behave. New words show up constantly. Riz, Sigma, Delulu. Whatever Gen Alpha invents next Tuesday. Names of people, made-up brand names, typos, slang, science jargon, someone's cursed Wi-Fi network name. The list is infinite. If you tried to give every possible word its own unique number, your dictionary would need to be infinite too. And the moment your model meets a word it's never seen, which happens constantly, it completely short-circuits. It's like teaching someone every word in the English dictionary except the word "the," and then being shocked when they can't form a sentence. You need something in between, something smaller than a word, but bigger than a single letter, something that can rebuild any word, seen or unseen, out of a manageable, finite set of pieces. That something is a token. So that's the problem tokens solve. Infinite words, finite pieces. Problem solved, right? Not quite, because tokens create a brand new mystery. Once you've shredded language into these little numbered pieces, how does a machine that only understands numbers figure out that king and queen are related, but king and banana are not? Nobody tells it that. It has to figure it out on its own, and the way it does it is honestly one of the strangest ideas in all of computer science. That's part 2. And honestly, this is bigger than one video. We're building a whole series, breaking down piece by piece how LLMs actually think. No jargon, no PhD required, just building the intuition. One weird idea at a time, until the whole thing finally clicks. If part 1 messed with your head a little, stick around, it's about to get a lot more interesting.